For generations our solar system was a settled family of 9, a cosmic truth etched into every textbook and planetarium show. But in the frozen dark, a phantom was waiting, a ghost in the machine of our celestial maps. Its detection wouldn't just add a member, it would fracture the entire family portrait, forcing science to wage a bitter, public war over the meaning of a single, sacred word: planet. 70 years of stable cosmic maps were about to be shredded, far beyond the last known worlds. Drifting silently in the archives of forgotten telescope images was a faint speck of light, a puzzle piece from the wrong box. It moved with a slowness that betrayed an almost unimaginable distance, a crawl against the backdrop of infinity. This wasn't just a new object to catalog, it was a direct challenge, a celestial rebel that refused to fit into our neat categories. And its discovery would ignite the most passionate and divisive debate in modern astronomy, a conflict that would spill out of academic journals and into the public consciousness. I'm Alex, and on Winds of Thought, we explore the ideas that reshape reality. Today, we journey to the solar system's outermost frontier to meet the world that dethroned a planet, the catalyst for a revolution. Eris. The tale of Eris doesn't begin with a sudden lucky sighting through an eyepiece. It starts with a deliberate, painstaking digital hunt, a testament to how modern astronomy is done. At California's historic Palomar Observatory, a team of astronomers, Mike Brown, Chad Trujillo, and David Rabinowitz, were conducting a meticulous census of the solar system's forgotten outskirts, the attic of our cosmic neighborhood. They were systematically searching for trans-Neptunian objects, the icy bodies orbiting in the gloom beyond Neptune, using a wide-field telescope and sophisticated software to scan for the telltale tiny movements against the static star field. Their work was already successful, populating the void with names like Sedna and Quaoar. But Brown was driven by a deeper, almost aesthetic conviction: Pluto couldn't be alone. The idea of a solitary planetary oddball sitting at the edge of everything seemed jarringly illogical, a flaw in the pattern. There had to be more, and he was determined to find the next one, the one that would make sense of it all. He began the tedious work of manually reviewing old data his software had dismissed, sifting through digital haystacks grain by grain. Then, on a day like any other, January 5, 2005, while examining a sequence of images from over a year prior, October 2003, he saw it, a single stubborn dot, inching its way across 3 frames. Its glacial pace meant it was incredibly far, perhaps farther than anything they'd yet catalogued. Its persistent brightness hinted at significant size or a strangely reflective surface. In that moment of recognition, Brown knew this was different. He had not just found another frozen rock in the dark. He believed with the excitement of a pioneer that he had found a legitimate planet, a 10th world for the solar system. The team scrambled to track it, gathering more data to pin down its path, giving it the dry, provisional label 2003 UB313. They hoped to keep their discovery secret until they could learn more, to own the narrative completely, but the competitive world of planetary science is a leaky vessel. When another group controversially announced the discovery of a different large object, Haumea, after potentially accessing Brown's team's public observation logs, the clock ran out. To avoid being scooped entirely, Brown's team was forced to reveal their hand prematurely. On July 29, 2005, they announced to the world 2 major discoveries, including the object we now call Eris. The secret was out, and the solar system was officially plunged into an identity crisis from which it would never fully return. The core problem was brutally, beautifully simple. Early measurements from its brightness suggested Eris was larger than Pluto. Soon, crucial data gleaned from the orbit of its tiny moon confirmed it was actually 27% more massive. The logical trap was sprung with finality. If Pluto, with all its cultural and scientific baggage, was a planet, then its more massive twin, Eris, must unequivocally be one too. And once that door was opened, what about the other large trans-Neptunian objects like Make and Haumea? Where would it end? The planetary roster was poised to explode from 9 to dozens, perhaps hundreds. The discovery forced a fundamental, uncomfortable question upon the astronomical community. Were we going to keep adding planets indefinitely, embracing a crowded solar system, or did we need to make a hard choice and remove one? This untenable situation forced the International Astronomical Union, the global governing body for astronomical nomenclature, to do something it had never done before: formally define what a planet is. The 2006 General Assembly in Prague thus became a battleground of ideas, a conference room turned courtroom. The debate fiercely split the community along philosophical lines. One camp, appealing to physical essence, argued for a geophysical definition. If an object is massive enough for its own gravity to pull it into a round shape, a state called hydrostatic equilibrium, then it is a planet. It's about what you are. This simple, elegant definition would include Pluto, Eris, the asteroid belt Ceres, and potentially many more, celebrating the diversity of round worlds. The other camp, focused on cosmic context, insisted on a dynamical definition. A true planet, they contended, must not just be round, but must also act like a master of its domain. It must be the dominant gravitational player in its orbital zone, having cleared the neighborhood of other significant bodies. It's about what you do. The final vote was contentious, and, many argue, flawed, taken on the last day when only 424 of the original 2,500 attendees remained. Resolution 5A passed. A planet must orbit the sun, be round, and have cleared its orbit. Pluto, swimming in a sea of similar Kuiper belt objects it does not dominate, failed the third test. It was a verdict based on celestial sociology rather than intrinsic geology. A new category was born from this compromise, the dwarf planet. Crucially, and this is the key semantic twist, it was defined as a separate class, not a subtype of planet. In 1/10 vote, our solar system was officially shrunk to 8 classical planets. The goddess of discord had rewritten the celestial rulebook. Critics immediately and rightly slammed the definition as vague. What does cleared mean exactly? And parochial, as it only applies to our sun, ignoring the thousands of exoplanets. But the deed was done. The team, with a sense of poetic justice, named their discovery Eris, after the Greek goddess of strife and discord, a perfectly fitting name for the world that had torn astronomy apart. So, what is this infamous, paradigm-shattering world actually like? Eris is not a resident of the relatively orderly Kuiper belt where Pluto resides. It belongs to a far more anarchic realm known as the scattered disk. Think of the Kuiper belt as a broad, dusty disk on the solar system's edge. The scattered disk is a sparse, spherical halo of gravitational outcasts. These are objects that likely formed closer in but were violently scattered into wildly eccentric and inclined orbits by Neptune's gravitational influence billions of years ago. They are the solar system's rogue exiles. Eris's path is a dramatic reflection of this violent history. Its orbit is a long, drawn-out ellipse, a cosmic marathon. 1 full year, on Eris lasts 557 Earth years. At its closest approach to the Sun, it comes within about 38 astronomical units, roughly Pluto's average distance. But at its aphelion, its farthest point, it voyages out to a staggering 98 AU. Nearly 15 billion kilometers into the deep freeze, almost 3 times Pluto's current distance. Furthermore, its orbit is steeply tilted, inclined at about 44 degrees to the flat plane where the planets orbit. This means Eris doesn't just go out and back in, it spends its centuries-long year soaring high above, and then plunging far below the rest of the solar system, a distant, lonely traveler on a wild ride. For years after its discovery, we operated under the assumption that it was physically larger than Pluto. Then, in November 2010, astronomers got a rare and precious chance to measure it with pinpoint accuracy. Eris passed directly in front of a faint distant star, an event called a stellar occultation. By coordinating observations from multiple telescopes across the Earth and timing exactly how long the star's light blinked out, they could calculate its diameter with incredible precision. The result was a shock. Eris's diameter is almost identical to Pluto's at about 2,226 kilometers, and in fact, it might be slightly smaller. This revelation was seismic. It meant that with more mass packed into a slightly smaller or equal volume, Eris is significantly denser than Pluto. This simple calculation of density points to a profoundly different internal structure. While Pluto is thought to be a roughly 70-30 mix of rock and ice, a frozen mud ball, Eris's higher density suggests it is predominantly rocky, with only a comparatively thin mantle of volatile ice on top. Imagine a rocky planet like Mars, but wrapped in a glittering shell of frozen nitrogen and methane. Eris is a rocky heart in a frozen shell, a world of a different character altogether. That shell is itself one of the most astonishing surfaces in the entire solar system. Eris has an albedo, or reflectivity, of about 0.99, meaning it reflects back 99% of the sunlight that reaches it. It is a brilliant, almost perfect mirror in the void, dazzlingly bright. Scientists explain this through a fascinating seasonal cycle of atmospheric collapse. Like Pluto, Eris likely has a tenuous atmosphere when it is closer to the Sun, composed of nitrogen and methane gas sublimated from its surface. But as its extreme orbit carries it out into the deep, centuries-long freeze of its aphelion, temperatures plummet so low that this entire atmosphere freezes solid and snows down onto the surface as a fresh, brilliant layer of frost. The world literally deflates, its air turning to ice. Then, as it slowly creeps back toward the Sun over 280 years, this frost layer warms and sublimates, renewing the atmosphere in a slow cosmic breath. Recent data from the powerful James Webb Space Telescope has added a tantalizing layer of mystery to this picture. Analysis of different isotopes of methane on Eris's surface suggests they may have been produced by geothermal activity in the distant past. This hints at the possibility, astonishing for a world so far from the Sun, of a warm, active, rocky core at some point in its history, a hidden engine beneath the ice. The definitive key to weighing Eris, the data point that made the planetary debate unavoidable, came from the discovery of its moon. In September 2005, using the advanced adaptive optics of the Keck telescope in Hawaii, Mike Brown's team spotted a faint companion orbiting Eris. They named it Dysnomia, after the daughter of Eris and the Greek demon of lawlessness, a brilliantly fitting choice. By meticulously tracking Dysnomia's nearly circular 16-day orbit, astronomers could apply Newton's laws of motion to calculate the mass of the system with precision. It was this calculation that definitively proved Eris was more massive than Pluto, transforming the philosophical debate into an urgent practical crisis. Dysnomia itself is a stark, dark contrast to its brilliant parent of one. While about a quarter of Eris's diameter, it is incredibly dark, darker than coal, suggesting a surface devoid of bright frosts, likely stripped of volatile ices during a violent giant impact that created it. It is a child of chaos, orbiting the world that brought chaos to astronomy. In the tumultuous aftermath of the IAU vote, Mike Brown was inevitably dubbed the Pluto Killer in the media, but this sensational nickname misses the profound point of his discovery. Eris didn't murder a planet, it performed a cosmic intervention. It revealed a truth we had been ignoring for decades. Pluto was never the misfit, our definition was. For years we tried to force Pluto into the Planet Club, but it was always the odd one out, hinting at a larger reality. Eris forced us to see the bigger, more accurate picture. Our solar system is organized into distinct dynamical zones, the rocky inner planets, the gas and ice giants, and beyond them, a vast third realm, the realm of icy dwarf planets, a populous frontier where Pluto and Eris are the largest known monarchs. This new map isn't diminished. It's richer, more detailed, and more truthful. Some discoveries provide neat answers in close chapters. The very best discoveries, however, rip those chapters out and show you how much of the story is still unwritten. They replace certainty with a more profound, more exciting wonder. Eris remains the most massive known object in our solar system that has not yet been visited by a spacecraft. While NASA's New Horizons gave us an intimate, beautiful portrait of Pluto, Eris remains a pixelated mystery, its secrets held across an almost theological gulf of space. A proposed flyby mission would take an estimated 25 years just to reach it, a journey spanning a generation. For the foreseeable future, the goddess of discord will keep her secrets, a distant brilliant speck that serves as a permanent reminder. Our maps of reality are always provisional, always subject to revision by the next faint point of light in the darkness, waiting to be noticed. If you enjoyed this journey to the edge of our cosmic understanding, to the moment our celestial family portrait was redrawn, help Wines of Thought explore more ideas that challenge and define our reality. Please give this video a like, it truly supports the channel and helps others find this story. Let us know in the comments. Do you think the IAU made the right, if painful, scientific call, or do you believe Pluto and Eris deserve the planetary title based on their intrinsic nature? The debate continues. Subscribe and hit the bell for more deep dives into the winds of thought, where we navigate the ideas that shape our universe. Thank you for watching.